Hi there, this is Steve Willett, and this is the app ROIstat that I wrote because I couldn't find any other software that did analyses, in particular measurement system analyses, the way that I would do them. You could usually get there one way or the other, but it would be a lot of extra work. So I put everything all in one place to make it easier for the user. This app is also very useful if you're learning statistics, all the way up to doing some pretty advanced analyses with analysis of variance. So let me show you a little bit about how this works. This is just the splash page here. In the file dropdown, it's kind of the usual stuff. You can import data. Most commonly, you're going to be importing from a local file that's on your hard drive. You might be pasting the data in from Excel or something like that. Occasionally, you might be using Google Sheets as well, so you can check that box there if you're going to be bringing data in from Google Sheets. When you have the selections that you want, open the import window. Here's where you would copy and paste data if you had it, or if you want an external file, you can go ahead and select that button there, and then browse to the subdirectory where your data lives. So in this case, we're going to use our potential data. Once the data is imported, it shows you a little sample of the data here just to make sure you've got the file that you think you've got. You can take a look at the entire file by clicking on View and just make sure it's what you want. It's got some information about each of the columns summarized up at the top here, which is a really nice feature. So when you're happy with the data that you've selected, click on Import Data, and it again shows you kind of a text output here to make sure that you've got the right data that you were looking for. Some other things you can do under File is you can select Rename and Convert the Variables. If you want to change the name of a column, you can do that right here. You can change what the column's considered. In this case, Jack and Jill are considered characters. You could change them to factors or anything else that you want to here. It tells you what the missing value indicator is. Tells you if you've got some missing data, because this would be less than 100%, and also the number of unique values that fall into each of these different columns. So there are only 2 different unique values, Jack and Jill, that fell within the appraiser column. If you do make any changes here, click on Apply Changes, and those will be applied to the working data set. You can dynamically filter the data based on the data type. So Jack and Jill were just 2 different character strings, and so if you want to get rid of all the Jill data, you just X that out, and then all the Jill data goes away. If you want to add it back in, you can do that or select all. If it's continuous type data, you'll see these sliders here, so you can filter on the variable values that you want on both sides. So anything between and including 2 and 7.2 are now included in the filter data that's the working data set. Kind of a nice feature down here too is if you're using R, it generates the code either using dplyr, if you're using that, or just base selections here, so that if you wanted to go back into R and get the same subset of data, you could just copy and paste that code and it'll work right in R. Okay, and then you can get the entire data that way. You can also do a current working data view, which is just whatever the data is that is currently going to be analyzed, however you have all the filters set up. You can take a look at all the data as it shows up there. Now under Edit, under Settings, I've got different color palettes you can choose from. The default color palette is trying to be a good balance between how bright the colors appear next to each other. So for example, a bright yellow or a bright red or a bright green doesn't seem more important than a less bright blue or a less bright cyan or something like that. Additionally, it tries to give people who are colorblind the ability to look at and be able to see the differences in the colors as well. But if you are colorblind, you may choose another one called a Kobe Ito. And this one's specifically designed for colorblind people to be able to easily tell differences in the colors, and for non-colorblind people to be able to easily tell the difference in the colors as well. So usually the default's okay, but if you do have some color blindness, then you may choose one of the others. If you want a lot of different colors or pastels or something like that, there are a lot of other options as well, but usually the R4 will work for most people. Okay, so that's kind of the basics there. Under distribution, this is if you're learning statistics, you can generate various distributions and what you might be interested in. So you can generate what that distribution looks like by changing the parameters. You can select a sample size if that's appropriate. You can also choose specific locations that you want to be interested in this case 3 or below. And then you can also show the table, so you get the full table for each of these different distributions. So you have those distributions for the common ones. Under critical values, this is when you're doing something like hypothesis testing. Depending on what type of distribution you're using, the z, t, chi-square, f, it'll tell you either the critical values, if you want the p-value, or if you've got a p-value and want to score, then you can do something like that to get the tail values for a given score. You can also do distribution testing here. So if you click on testing, you can test to see if the distribution is Poisson, normal, or exponential. Let's say we're looking for normal. You can choose the different tests that you're interested in, how you want to look at the data. Are you analyzing the entire column or analyzing by factors? So let's say we're analyzing by factors by two different appraisers. And you can see whether, there's a density plot here that's based on the data that you see. So since it's normal data, we're assuming it's continuous data. It's got a distribution of what the normal distribution would look like if the average and standard deviation of the data itself was exactly a normal distribution. And then down here, it's got the selected normality tests that you've selected up here. For all these graphs, you can download high quality or lower quality versions of them. SVG is vector graphics. You can also use download in a number of different formats depending on what's going to work for you. So if you want some output to show up in a report of yours, you can just download that in a high quality or lower quality format depending on what you need. You can calculate the sample size and power for any number of different types of hypothesis tests that you might be doing, as well as tests within each of those. You can choose to whether the alternative is going to be a one-sided or two-sided. And then if you want to get and then it does the calculations, for example, for the means for z-test, you can enter your alpha, beta, sigma, and delta, and it'll tell you the sample size necessary in order to detect that delta with a given alpha and beta. If you instead want to calculate the power, then you can just check the box here in power, enter the sample size that you want, and then calculate the power down here for you. Now under exploratory data analysis, that's what EDA stands for. You can just get an idea of the statistics of the data that you have. So let's go ahead and again put in factors. So for our two appraisers, we're measuring hardness. We'd like to get the descriptive. So here you can get for each appraiser the sample size, mean, standard deviation, min, max, and range. And then there's a lot of other statistics you can choose depending on what it is that you are looking for from your data. You can do some normality tests here, the more common ones. And so again, it's split by the two operators, tells you the sample size. And here we're doing the Anderson-Darling and Shapiro-Wilk skewness and kurtosis tests. We're auto-selecting this based on the sample size. If you prefer to select the tests on your own, you can choose manually Anderson-Darling, Shapiro-Wilk, or skewness and kurtosis tests. If you need more fineness and different types of testing, you go back to distribution testing over here. You can get your box plots and change the size of the box plot depending on what it is that you need to display what you are trying to display. You can choose a violin plot. All that is a density plot that's mirrored on either side to kind of give you an idea of the shape of the distribution. That's really only relevant for continuous data, and if you don't have a lot of data, then it may give you some kind of weird shapes here. So usually a box plot looks pretty good. If you want, you can add a notch to the data or not. You can add the title, the X label, and the Y-axis if you want, or choose a larger font if you're going to be downloading that for publication. And again, you can download that in any of the various different formats. We can generate some histograms. Again, I can make those histograms a little bit wider, a little bit taller to display what it is that I'm looking for. I can also select frequency polygon, which is going to be more useful if you have a higher number of data sets or data points. The kernel density plot is that density plot that we were talking about before, which here it's not going to be particularly useful because we have what's clearly some bimodal stuff going on in the data. And because of the density plot doesn't show you the actual data points themselves like the frequency polygon or histogram does, by default it has a rug diagram here which puts a tick mark everywhere there's an actual observation in the data. So you can see exactly where the data are versus what the density plot is estimating. You can also extend that density down to the bottom of the y-axis if that's what you're trying to do as well. You can calculate quantiles, quartiles, deciles, ventiles, percentiles, or any other tiles that you want just by clicking on that there. You can also calculate confidence intervals. Confidence intervals require normality and some other things to be helpful. You can also do Bayesian credible intervals where it does multiple tests to generate the true credible intervals. The idea here being that the true value of the mean has, in this case, a 95% chance of being between the lower and the upper credible interval for Jack and Jill. And the same thing with the standard deviations. Okay. And if the data happen to be normally distributed, you can calculate a natural tolerance, which is based on the observation of the data, the specific average, and the standard deviation. And you can, if you have exponential data with using the lowest point as the low of your exponential data, or exponential data using a 0 point as the low, you can get a natural tolerance for that. Okay. Under 1 and 2 sample tests, there's a test reference to help you select the right test. You can do mean and dispersion testing, proportion, Poisson, and then a variety of non-parametric tests. Under correlation and association, you can do either hand entry of the statistics to do a variety of different 1 and 2 sample correlation association tests. If you have data that's correlation data, you can calculate the various correlation coefficients and their significance, and you can also do a scatter plot. If you're doing analysis of variance, you can do one-way analysis of variance or multi-factor analysis of variance. Some pretty complicated designs, including fractional factorials and mixed effect types of analysis of variance. If you have statistical process control data, you can do SPC by going over here and choosing what type of variable or attributes control charts you want to, setting up the data, and then it'll generate the control chart for you. And then finally, for our purposes, we can do measurement system analysis for continuous and discrete data, but I'll leave that for when we get into the class. So this is a very flexible and pretty powerful program that allows you to do a variety of different statistical analyses correctly and very quickly as well, using just a graphic user interface instead of having to learn R. I hope you enjoy it. Let me know if you've got any suggestions for anything you'd like to see as part of ROIstat.